So this last lesson in Module 5 is kind of putting together everything that we have done so far on Module 5. All the different types of factoring when you have a greatest common factor, and factoring, quadratics and all of that. So the first thing I want to look at is, do I have a greatest common factor, a GCF, that I can factor out? So what is the biggest thing that I can factor out of all of the terms in this polynomial? So we've mentioned before, or I've mentioned to you before, that if every term has a variable, you can factor out the one with the smallest exponent. So I can take x squared and factor it out of all three of these terms. But I see that they're also all positive. I've got 2, 4, and 8. So I can also factor the smallest, or I can factor a 2 because they're all even. It won't always necessarily be a number that's there. In this case, it is, but it just depends on what they have in common. If that first number had been, say, a 6, then I still would have only been able to factor out a 2. All right, so once I have factored that out, I have to keep my 2x squared. I can't just get rid of that. But I'm going to factor out, here's the 2, and then the x to the 5th over x squared becomes x cubed. 4 over 2 becomes just 2. And then x cubed over x squared is just x. And then 8 divided by 2 is 4, so it's going to be minus 4. And then my x squareds become 1 when you factor those out. And while I have a trinomial here, I have something with 3 terms, I don't have an x squared. So I'm going to stop factoring this right here, and that's as far as I can go with that. All right, so let's take a look at another example. The first thing that pops out at me is all 3 of these things are multiples of 3, so I can definitely factor a 3 out of each one. And I'm going to write that over here just to save some room. So I'm going to put the 3 on the outside of the parentheses. That gives me x squared plus 3x minus 6. Now, I have a quadratic inside my parentheses. So the next thing I need to do is see if I can factor that down any further. So the way that I do that is I make my x and I say, okay, I want numbers that multiply to -6 that add to +3. So if I run through if I'm positive, or if my factors multiply my product, is negative, one has to be negative, one has to be positive. And if they add to a positive number, the positive one would have to be bigger. So if I'm looking at my factors of -6, if I make the larger one bigger, or the larger one positive, that's -1 and 6, -2 and +3. So none of those things factor, or none of those things add up to 3. So for the purpose of what we are doing right now, this is as far as you can factor this. So this would actually be your answer. But I had to do this part to check and see if I could factor it down any further. All right, so let's look at an example where you can actually factor it down further. So I notice again that each of these things are positive. That looks to be about the only thing that they have in common. So I can factor a 2 out of each one. So I'm going to pull the 2 to the outside of the parentheses. 6x squared divided by 2 is 3x squared. -10x divided by 2 is -5x. And then -56 divided by 2. I know 56 is even because it ends in a 6. That's actually going to be -28. Okay, so now I need to see, can I factor these two things? Now I'm going to give you a hint. Before you go to all of the effort, you could put these two things in a calculator and just in a graphing calculator, or sorry, just this part right here in a graphing calculator and see if it crosses the x-axis. So if it's way up here, you can't factor it. But if it's down here where some part of the graph is touching the x-axis, then you know that you can factor it and it's worth the effort to do it. If you graph it and you find that it doesn't touch the x-axis, then that means that there's no point in factoring it. But this is factorable, I know that. So I'm going to do 3 times 28. 3 times 28, 3 times 8 is 24. So that would be 84, right? 3 times negative 84. And negative 5. So I know because 84 is negative, I need a negative and a positive. And because the negative or the 5 is negative, the negative number is going to be bigger. So I need to look at my factors of 84. And because 84 could have quite a few factors, I'm going to go ahead and check them as I go through. So 1 and negative 84, definitely not going to add to 5. 2 and negative 42, not going to add to 5. 3, 3 and sorry, 3 and negative 28, I just lost my train of thought. 3 and negative 28, not going to work. 4 and 21, negative 21, not going to work. 5 won't go in there. 6, 6 will go in there. I'm going to start another column over here. 6 and negative 14. We're getting closer though. What about 7? 7 will go in there. 7 will go in 12 times. So 7 and negative 12, there's my negative 5. So now I'm going to go ahead and do this factor by grouping. I have to keep my 2 out here. I'm going to split my 3x squared into minus 12x plus 7x minus 28. And I'm just going to leave the 2 kind of sitting off here to the side while I do everything else. So 3x squared minus 12x and 7x minus 28. So that's going to be 2 times 3 and negative 12 both have a 3 and an x that will factor out. So that's going to be x minus 4. And then I want this over here to also be x minus 4. So that means plus 7. And so if I scroll down just a little bit here to give myself some space to write, I have 2 times x minus 4, and then my 3x plus 7. Okay, so just pause for a second if you need to get that written down. I'm going to go ahead and go on to number 4. All right, so number 4, last one here. Factor completely. I actually have to erase this up here, so copy this down if you need it. Okay, so the first thing I see is that every one of these is divisible by 3, and there is an x in each one. So I can divide each one by 3x cubed, because x cubed is the smallest x. And that gives me 3x cubed on the outside. And then x squared plus 8x plus 12. So this one's actually a fairly easy one to factor because we don't have a number in front of the x. I do know that this one is factorable because I made it, but if you needed to, you can always, again, go and graph. And if you find that it does not touch the x-axis, then it is not factorable. If it does cross or touch the x-axis, then it is factorable. And so I'm going to do my x over here. I want to find the factors of 12 that add up to 8. So to make this a little simpler, I'm going to do, I know that that's 2 and 6. So the fully factored form, the fully factored form of this right here is going to turn into x plus 2 and x plus 6. And so this is the fully factored form of that that expression. So if we were to go back through and we were to multiply, x times x, x times 6, 2 times x, 2 times 6, and then whatever we get, we then multiply everything by 3x cubed, that would bring us back to our original expression of 3x to the 5th power plus 24x to the 4th plus 36x cubed. All right, that's it. There will be some more practice coming tomorrow with this, so stay tuned for that.